Well, thank you everyone for tuning back into this Good New World series. It's supposed to be a weekly podcast, but I've been on hiatus, sabbatical for the last 2 weeks. So I apologize for those that tune in and I wasn't there. There was a good reason for that. The past couple of weeks, I've been in Los Angeles, Hollywood specifically, with my Clydesdale partner and wife, Andrea Wen. She was promoting her globally acclaimed and multi-awarded international film, The Man Who Met God, which was premiered, those that know, a few months back in Istanbul at the Milano Supreme Foundation as part of the World Congress event. So it's come full circle because of that Istanbul event. We kickstart the Good New World series with New Life, which was the first episode in this series. And like I said to you, we had this 2 weeks interlude in Grand Los Angeles, where, like I said, Andrea and myself were recognized by the film industry, thanks to the family at Manatorium. Specifically, a shout out to Ashkan and his fellow Manatorium, Henning, who's the CEO, and Lester Bailey, who's we as known as Chief. So that was the good excuse to postpone for 2 weeks this Good New World series. So now we come to returning. So we've done the first Holy Trinity, which was the art, which was new life, new mathematics, new commandments, and then the second Holy Trinity with business related, which was new exploration, new collective, and new governance. And now we're on to the third and final Holy Trinity, which is the charity part. We already done the new humanity, and this is the eighth of the ninth series, and this one is new science. And then next week, assuming we go by our weekly schedule, will be the final cycle, which will be new religion, and then we'll cycle back again. So anyway, I'll dive straight into this new science, which is those that know me is my divine path to God. But I am those that also know me. I am a nuclear physicist. So when I say I know my science, a little bit of the math, I'm speaking from a lot of academic experience. So if you just bear with me, I'm going to share my screen with you. Bear with me. So. Sorry about that repeat audio. That is from the live stream on your YouTube. So it's just getting itself up and running. So my apologies for that. But let me share the screen that I wanted to share with you. So hopefully you can see this new scientific discovery of the twin universe, which I arrogantly state will one day win me the Nobel Prize in physics. Not because I state it, not because of my good looks, but because the science that I'm delivering, I believe, and answers all the cosmic unknowns. And and I'm just going to go through each one of these in order of why this twin universe is, in my humble opinion, is the correct theory that quantitatively explains all the universal cosmic unknown, which obviously the greatest discovery, of course, is the single omnipotent consciousness, which is God. But for now, we'll stick with the science, okay? So here I have a chart which lists the comparison, the observation of what we can discover and see in our current mainstream science, which is interpreted as a single universe that we exist in, which is a four space-time. And then opposing that in comparison is the twin universe. So the first observation is the laws of thermodynamics. Laws of thermodynamics is actually the most fundamental component of physics. Everything, literally everything, is embedded, built on top of this foundation, The laws of thermodynamics is actually not a derived equation or theory. It's just based on fundamental observation. And the most known one is the first law of thermodynamics, that energy cannot be destroyed or created. And the second law of thermodynamics, entropy is always increasing. There's a third one, but that's you cannot reach absolute zero. But we'll stick to those two fundamental laws of thermodynamics. Well, in the single universe, it already disobeys the conservation law. Now, a lot of my physicists will state, "Oh well, the universe don't have to obey the laws of thermodynamics." And then I'm asking them, "Well, first of all, why not? Why shouldn't the universe obey the laws of thermodynamics? If the laws of thermodynamics are fundamental, and everything, literally everything, obeys it, whether it's a grain of rice, a micro, an atom, a vibration, wave, whatever. If everything in the universe obeys the laws of thermodynamics, then why shouldn't the universe itself obey the laws of thermodynamics?" And they can't give an answer to that other than, well, it doesn't have to. Well, it does have to. If fundamentally everything, and if the universe includes everything, then by definition, the universe must obey the laws of thermodynamics. So the single universe that will already defies that, because where's all this energy in our universe come from? So it defies the universal law. Twin universe answers that question, because in twin universe, the positive and negative universe are opposed and parallel to each other, so they cancel out. So before the existence of the universe, there was zero energy, zero entropy. Well, guess what? At the moment creation, because there's parallel universe, one with positive values and one with negative values, exactly the same amount quantity-wise, then when you add 2 plus minus 2, guess what? You end up with 0. So the twin universe fundamentally obeys the fundamental laws of thermodynamics. So it's that simple, okay? But beyond that, there's other explanations that are delivered. So the other one, which is dark energy, which mainstream science cannot explain. They measured it about 2 decades or 3 decades ago, the expansion rate of the universe, and they was expecting the universe to be expanding, but depending, one of the expectation was that the universe will eventually slow down and maybe go back into a big crunch, falling us out, or it'll just steadily expand at a steady rate. But science discovered that not only was it expanding, but the expansion was accelerating. And again, current mainstream science cannot explain that. So they just give it a term, dark energy. Dark means it's in the darkness. They're in the darkness, basically. Well, guess what? With the twin universe model, I was able not just to qualitatively explain it, but I could numerically calculate predictive values, which miraculously, although it's not a miracle, is the reason why it matches observation, is because it's the right theory. So I was able to explain the expansion rate of the universe using a stellar nuclear fusion event in stars, which are already known parameters, but I interpreted that in star-like objects, not only in our own universe, but in the negative universe as well, with negative gravity. And based on that, I was able to determine value, which matches miraculously, but it's not miraculously because it's the right theory. That's why the expansion of the universe. So that's another tick for the twin universe that the single universe cannot explain. Then there's dark matter. Again, cosmologists and astrophysicists measure the rotational velocities of galaxies. And again, they found that the galaxies were rotating way, way too fast. In fact, it was rotating so fast that the galaxy should basically explode outwards. There's not enough matter to keep the galaxy together. So again, because it's unknown, they used the word dark matter. Dark again, meaning that they're in the darkness, they don't know. But again, miraculously, again, not miraculously, simply because this theory is correct, you can explain the dark matter as a space-time compression of the galaxy from the space-time itself, which relates to the dark energy above. Basically, the stellar stars are creating a wave of repulsive gravity from the energy that is released from the fusion stars in the negative universe. But that not only spread the space-time apart, but between the space-time, it compresses the galactic star clusters, the force itself, and that's what gives it the galaxies the compressive force to hold its shape while it's rotating at much faster speed. So that's three ticks for the twin universe. Then black holes. Again, the general theory of relativity of Einstein predicts gravity as curvature of space-times, and it does have a lot of properties that are accurately predicted. But within a black hole, which has infinite mass, infinite radii, you have a singularity where the mass approach infinity, and it just science basically physics just breaks down. And so there's no theory that can explain such a singularity or infinity. And again, guess what? The twin universe can explain that in the sense that the collapsing black hole is held with the pressure of Planck particle. Basically, a Planck length, a Planck time is the smallest divisible quantity of a value of an entity. So a Planck length, which is I think 10 to the power, I've gone 10 to the power minus 43, that's time, but it's very, very small quantity basically. But there's also what's known as a Planck volume. So the individual Planck entity, because in the negative universe it has repulsive gravity, this Planck star is the smallest entity that can basically hold a black hole, because it has the actual Planck volume, which is equated to its mass. It therefore do not collapse into infinity, and therefore, again, based on twin universe, physics still holds up because there's a finite uh, size, volume, mass for black holes in the twin universe model, so that it does not have to, defy physics by breaking down to a singularity. And one of the biggest unknowns that people have been trying to get, where's all the antimatter? You know, those that know is that if you bring matter and antimatter together, they explode and just create pure energy. So our universe has a surplus of matter. Otherwise, if there's a matter antimatter, we will not exist because we literally just disintegrate into nothingness. So in our universe, for every one antimatter, there's 1 billion matter, and that's why we exist in the present form. But the laws of physics seem symmetrical. So therefore, the big question is, where's the antimatter? There should be an equal amount of antimatter and matter in the universe. But again, the twin universe solves that in the sense that here in our universe, we have matter and antimatter, which is 1 part to the billion. In the negative universe, we also have antimatter and antimatter, but in reverse quantity. So the matter here has an antimatter component in the other universe, and similar antimatter has an antimatter component. And again, just like above the laws of thermodynamics, you add the positive and negative quantity together, they balance out. So that's where it provides balance with the twin universe theory. So there's no missing antimatter. You just can't observe it because it's on the other side of the universe. And again, the next step is listing the matter to antimatter ratio. Science not only cannot explain why there's no antimatter, but it also cannot explain the ratio between matter and antimatter, which is 1 to 1 billion component. Well, again, with the twin universe and using a orthogonal mixing of superparticles, orthogonal in the sense that the positive universe and negative universe exist in orthogonal component, you want to call it. So there's a real component and there's an imaginary component. So it has a real effect, a real sum effect between the two vector component. But the two, because they're orthogonal in phase, they cannot actually see and interact with each other directly. So we use that and do the calculations, which again, through this series, I will get to those and go into more detail, each of these specific components, but I'm just going give the highlight moment of each one. You can actually calculate, and again, miraculously, but it's not miraculous because there's a theory that's correct that explains everything. You can actually calculate the actual exact ratio between matter and antimatter that you see in both the positive and negative universe. Then there's this ghostly phenomenon called quantum entanglement. Basically, in our universe, when we have two entangled photons or quantum state, and you release them, when you interact with one of these uh, particles, its entangled twin immediately and simultaneously feels that interaction, even though they may be either side of the universe. Now, this violates Einstein general theory of relativity, special relativity, actually, that nothing can move, including information, can move faster than the speed of light. Like, for example, the sun takes, I think it's like 8 minutes for information to come from the sun to Earth. So, if we have two entangled particles, one on Earth, one on the sun, in principle, if you interact with one of the particles, it should take 8 minutes before the other particle feels that effect. But the quantum entanglement phenomenon shows that no matter how far apart these entangled particles are, when you interact with one, the other one instantaneously feels the same effect. So again, current science cannot explain that, but the twin universe can, because the twin universe says that every twin particle here in this positive universe has a twin particle in the negative universe, and every particle that has a solid state is a wave state in the other universe, and vice versa. So in a wave state, you have what's known as superposition of waves. So waves basically adds up just like your audio sound wave, added up from multiple frequency of sound vibration that adds up into a component. Same with water wave. You pour two buckets of water together, they merge as one and create one single wave. So one single wave, what happens is when you hit one single wave, the other wave, because it's superimposed onto it, instantaneously feels the effect. And that's why you can explain the phenomenon of quantum entanglement. Okay. And the photon stability, that leads on to the missing antimatter, because if you have a missing antimatter, basically you have a imbalance in the baryonic number. Baryonic is a quantity of protons and neutrons. There was an imbalance of baryonic number. Then science predicts that the proton should also decay. We know free neutrons at least will decay in like 10, 15, 14 minutes. Half-life is actually quite difficult still to determine. People are still debating about that. But protons, uh, for all the measurement, have been found to be totally stable. So that does not equate to a imbalanced baryonic number. But because in the twin universe, the barrier or matter and antimatter is balanced, which means that baryonic number is balanced, which means by definition, then the protons should be stable. So the twin universe do account for proton stability. And finally, the number of dimensions in a single universe, as we know, is 4 space-time, 3 spatial, 1 temporal. And in the 10 universe, like the string theory or the supersymmetric string theory, it actually has 10 dimensions. There's 4 dimensions for the positive universe. Again, 3 spatial, 1 temporal for the positive universe. For the negative universe, it also has 4 dimensions, 3 spatial, 1 temporal. So that makes 8. But then where the other remaining 2 comes from? Well, the 2 positive and negative universe are attached to each other through a membrane, a 2-dimensional P membrane, which gives you your 10 dimensions. So you can imagine that positive and negative universe are like Siamese twin stuck together back to back. So anyway, so that gives you a summary of why I arrogantly state the twin universe is the correct theory, because it qualitatively and quantitatively explain all the cosmic unknowns, and ultimately the biggest discovery, of course, of all time is that it can also explain the existence of a single omnipotent consciousness, which is God. So thank you again. Much love, peace to you, and the Clay Star blessing to you all. So thank you. Next week's series is the final of the season 1, which will be the new religion, and then we'll cycle back again. So see you next week.